In the vastness of the universe, humanity has always peered into the night sky with a sense of wonder and curiosity, yearning to answer one of the most profound questions of existence. Are we alone? For centuries, philosophers, scientists, and dreamers have contemplated the possibility that other worlds might harbor life. Now, thanks to the extraordinary capabilities of the James Webb Space Telescope, we are closer than ever to glimpsing a potential answer, as new revelations about Proxima Centauri B, an exoplanet orbiting our Sun's nearest stellar neighbor, have electrified the scientific community and captivated the public imagination. Proxima Centauri B, or simply Proxima B, lies just over 4 light-years from Earth, a mere stone's throw on the cosmic scale. Orbiting the red dwarf star. Proxima Centauri, this exoplanet has long been of particular interest due to its location within the so-called habitable zone, where conditions might be just right for liquid water to exist. But until recently, the evidence for its habitability consisted largely of tantalizing hints and educated speculation. That all began to change with the deployment of the James Webb Space Telescope, whose unprecedented sensitivity to infrared light has allowed astronomers to peer deeper into the mysteries of Proxima B than ever before. Through months of meticulous observation, the James Webb Telescope has gathered light that has traveled across interstellar space, filtering through the thin veil of Proxima B's atmosphere before continuing on to our instruments. By studying the subtle fingerprints these atmospheric gases leave on the starlight, scientists have begun to piece together a picture of what Proxima B's environment might truly be like. The findings, though still preliminary, have rocked the world of astronomy and opened up an exhilarating chapter in our search for life beyond Earth. The most significant revelation is the detection of key atmospheric components: nitrogen, carbon dioxide, and, most intriguingly, traces of water vapor. The presence of nitrogen is particularly promising, as it forms the bulk of Earth's own atmosphere, serving as a stable, inert background in which more dynamic chemical processes can unfold. Carbon dioxide, meanwhile, is essential for regulating temperature through the greenhouse effect, potentially keeping Proxima B warm enough to sustain surface water. But it is the faint signature of water vapor, molecules drifting through the exoplanet's skies, that has set imaginations ablaze. After all, on Earth, where there is water, there is life. These atmospheric discoveries point to a planet that may possess a dense, heat-retaining envelope, capable of distributing warmth from its eternally sunlit side to its dark, frigid hemisphere. This is crucial, because Proxima B is almost certainly tidally locked, with one side perpetually facing its host star and the other shrouded in endless night. On such worlds, the presence of a thick, dynamic atmosphere could mitigate the otherwise extreme temperature differences, creating a more temperate band where conditions might be stable enough for life to flourish. Yet the story is far from simple. Proxima Centauri, the star around which Proxima B orbits, is a red dwarf, a type of star known for its volatility. Red dwarfs are infamous for their intense stellar flares, which unleash torrents of radiation that can strip away planetary atmospheres or bombard the surface with lethal energy. For Proxima B, this means that any potential biosphere would have to endure an environment far harsher than anything found on Earth. The question of whether life could arise and persist under such conditions remains open, but the mere fact that Proxima B appears to have retained its atmosphere is a hopeful sign. The implications of these discoveries stretch far beyond a single planet. If Proxima B, so close to a tumultuous star, can maintain the basic ingredients for habitability, then perhaps similar worlds are common throughout the galaxy. The James Webb Space Telescope's findings have emboldened astronomers to redouble their search for biosignatures, those elusive chemical markers that might betray the presence of life. But what exactly constitutes a biosignature? On Earth, life has dramatically altered the composition of our atmosphere, filling it with oxygen, methane, and other gases in concentrations that would be improbable without biological activity. Detecting such combinations on another world would provide compelling evidence that something, Perhaps even someone is alive there. However, the search is fraught with difficulty. Many chemical processes, both biological and abiotic, can produce the same signatures. Confirming the existence of extraterrestrial life thus requires not only exquisite sensitivity, but also careful, skeptical analysis. The James Webb's initial survey of Proxima B has not yet uncovered definitive biosignatures. No unmistakable whiff of life, such as an oxygen-methane pairing in disequilibrium, has been detected so far. But the very presence of water vapor and a stable, complex atmosphere is a major leap forward. It suggests that Proxima B is not a barren rock, but a dynamic world where the conditions for life may exist. With further observations, scientists hope to delve deeper, searching for more subtle signs, seasonal variations, unexpected chemical imbalances, or perhaps even the spectral fingerprints of complex organic molecules. The road ahead is long and challenging. As NASA scientists have cautioned, finding biosignatures is a painstaking process, requiring vast amounts of observation time and the ability to rule out false positives. Yet, the excitement is palpable. Each new piece of data brings us closer to an answer that would have profound consequences for our understanding of life and our place in the cosmos. The discovery of water vapor on Proxima B is not an isolated event. In recent years, astronomers have detected possible chemical signs of life on other faraway worlds, such as K2-18b, where unusual concentrations of gases have sparked speculation about alien biospheres. Across the galaxy, the James Webb Space Telescope and its successors are turning their gaze to hundreds, even thousands of exoplanets, searching for the telltale signs of biology. Each discovery adds a piece to the puzzle, building a picture of a universe that may be far more lively and far more diverse than we ever imagined. But even as we celebrate these breakthroughs, it is important to remember how much remains unknown. The universe is vast, and the processes that govern planetary atmospheres are complex and multifaceted. It is entirely possible that we may find worlds that seem, by all appearances, habitable, yet are utterly devoid of life. Conversely, we may stumble upon planets with exotic forms of life that leave biosignatures utterly unlike those on Earth. The search for life is not just a quest for confirmation, it is an exploration of the full spectrum of what is possible. For now, the revelations from the James Webb Space Telescope invite us to dream. They remind us that our own planet, with its blue oceans and teeming forests, is not alone in the universe as a crucible for life. Somewhere, perhaps on Proxima B, perhaps on a world yet undiscovered, the spark of life may have caught hold, struggling to endure in an alien sky. As we look up at the stars tonight, we do so with a renewed sense of connection to the cosmos. The light that left Proxima Centauri 4 years ago has traveled across unimaginable distances, carrying with it the secrets of another world. That we can now intercept and decode this message is a testament to human ingenuity and curiosity. In the coming years, as telescopes grow ever more powerful and our techniques ever more refined, we may finally glimpse the answer to the age-old question, are we not alone? The potential discovery of life on Proxima B would not merely be a scientific milestone. It would be a moment of profound philosophical significance, reshaping our understanding of what it means to be alive and what it means to be human. For as long as we have looked to the stars, we have sought companions in the void. Now, we stand on the cusp of an era in which those companions may at last reveal themselves. In the meantime, the story of Proxima B serves as a powerful reminder of the importance of exploration. Our drive to understand the universe, to probe its mysteries and seek out new worlds, is one of humanity's greatest strengths. It pushes us to build new tools, to ask daring questions, and to imagine realities far beyond our own. And so, as the James Webb Space Telescope continues its silent vigil, gathering photons from the edge of forever, we wait with bated breath. With every observation, with every spectrum analyzed and every anomaly investigated, we move closer to the day when the answer will come. A day that may forever change the way we see ourselves and our place in the grand tapestry of the cosmos. Until that day arrives, we can only marvel at the wonders yet to be discovered, and take solace in the knowledge that, no matter the outcome, the journey itself is a triumph of the human spirit. For in seeking life beyond Earth, we reaffirm the value of our own, fragile, precious, and filled with hope, under a sky that is no longer quite so empty.